It's a while since I've built a kit, so I thought, okay, let's build a kit. And this one is particularly notable because it appears that people have been having a problem with timekeeping with it. And that's strange, because this does actually use a DS1307 real-time clock. And what that means is it's a standalone chip here that operates in conjunction with a crystal, and it should keep perfect time, but they say it drifts quite significantly even when it's off. So I really want to try that out and see what happens. As with many Chinesey kits, this one actually came from the UK. You can get it from China a lot cheaper. I think I paid about just short of £10 in the UK, but you can get it for £6 if you buy it directly from China. And as with many of these kits, it comes with no real instructions, but that's okay. We can improvise. It's usually fairly clear. I'm not sure about the setting of it, but let's tip everything out. We've got a microcontroller, an IAP microcontroller. Interesting. We've got the real-time clock chip, we've got a little battery holder, we've got spacers and bolts for assembling the case. We've got a mini USB connector, not micro, and a matching lead to power it. It doesn't come with a battery, but that's okay. And it comes with a little 32.768 kilohertz crystal. Anyway, let's cut to the mustard and start building it. So anything really obvious to start off with. Let's zoom down here a little bit. Things that I should really look out for. All the components are marked on the side they go on, including the buttons. On the back we have the displays. We've got the battery holder. We've got the buzzer, a transistor for the buzzer, a capacitor, another capacitor. They must just be for power supply, so decoupling. Okay, so let's start with the easiest bits first. We've got, how many resistors? We've got 1, 2, 3, 4, 5, 6 resistor positions. They've supplied more than 6 resistors. They've supplied 8 resistors. Not sure why. When I'm wanting to remove components out in bulk, I just tend to cut them like with a pair of scissors. Not your mummy's best sewing scissors. It's a bit disastrous for sewing scissors. I often got chastised for that when I was young, for grabbing the nearest pair of scissors, and then my mum would have a rant about how I'd ruined her sewing scissors, which is true because it takes very sort of fine scissors to cut material. So let's start by putting these resistors in. It seems like a good component choice to start with. And for a start, people will instantly pick on me for putting the bending the resistor leads just with my fingers like this, but most people do that. If I was building military precision equipment, then I wouldn't be just folding like that. I'd be carefully bending leads one by one with a pair of special component formers. But to be honest, when you're building something like this, just squish them down with your fingers and ram them in. It's the easiest way. So let's get these resistors all mounted and then solder them. So there's 6 of these resistors. It's nice that they're all the same value. I wonder if they're primarily for the display. I'm guessing there might be 5 for the columns of the displays. Not sure. It does seem an unusually low number of resistors. It would be interesting to see the schematic just for that. Let's see if I can put them all in the same way around, or just randomly put them in different directions, because that also riles some people. You may notice there's a bit of noise in the background. I've got a fan running. It's a fan heater, not because I'm particularly cold, but because the background noise stops the microphone in this phone cutting in and out. It's got this thing that, because the house is very, very quiet, just like how I like my houses, it tends to cut in and out quite oddly on a noise gate thing, and I can't disable that feature in that particular recording device. So let's solder these, and the solder pads are absolutely minute. So I'm going to solder one leg of each of the resistors, and then I'm going to check they're all aligned, and then solder the other one. So by pressing the circuit board exactly in the middle, it's going to pin these down onto the workbench with the resistors held in place. Okay. And then I shall check that those resistors are all nice and flat. They are. So let's solder the other pins of those. As always with soldering, apply the soldering iron and the solder to the pad and pin that's being soldered together, because they have to be hot at the point the solder is flowed on. Don't do what a lot of people seem to do when they start with soldering and they put some solder in the soldering iron like this and then they try and carry it over and put it on. That doesn't work because if you watch carefully, when I put the solder on this, you'll see the vapour come off. That was the flux. It's gone now. The flux was needed to actually mate. It cleans the surfaces at the point of the soldering and mates the solder onto the metal. So you have to apply the solder directly. If you've been soldering by just carrying the solder across at the moment, this will be a revelation. And you'll suddenly discover that when you do it this way, suddenly it works really well. So that's looking pretty good. I think I'll add a tiny bit more solder to that one. These are tiny pads. Unnecessarily tiny pads, but that's okay. It's what they've done. So let's crop those. I've always been a fan of making big component pads and leads, tracks on the circuit board, just because it just makes everything chunkier and more robust. Other people complain that I am cutting the leads like this quite close to the solder joints after I've done it, and they'll announce that it cracks all the solder joints. No, it doesn't. Never had a problem that way. This won't stop people disagreeing, it's just what happens. So now we have 2 spare resistors. Do we have any other resistors on this board anywhere? No, that's it, just 2 spare resistors. That's going to confuse some people. What shall I mount next? From that side, I'm going to leave the chips till last because they are the most delicate components. Let's mount the buttons, except for one problem. The button here comes directly under the battery holder. The battery holder does appear to have pins for aligning it, and it is a surface mount component, and it sits down absolutely flush. So these pins of the switch are going to get in the way. So let's put the switches in. And these are little clicky tactile switches. They're very cheap and very common. So let's put these in. Make sure the leads are bent round the correct area. They've been squished in the packaging. And sat down fairly level. Okay, and I'll put the one in the other side as well, since these have their leads shaped to hold them into the circuit board once they're pressed in. So this one isn't such an issue, so I'm going to solder this one first. But the other one, I think the leads will have to be cropped before they get soldered, and possibly soldered from the other side, because otherwise they are going to stop that battery holder sitting down. Okay, that looks pretty good. The other side, I'm going to solder the 2 outer leads first, like this. And then I'm going to crop the leads. Touch more solder in that one. There, flush with the circuit board so it doesn't interfere with the battery holder. And because this is double-sided board, looks pretty good, I shall solder those pins from the other side. So I shall flow solder on like this. Looks good. I say that, I've not clicked the button yet. With some switches, if you linger with the solder iron too long, it knackers the switch. These are not too critical that way though. That looks just fine. So now I've done that, I kind of want to put the battery holder on now. So that is sitting down nicely. And what I'll do here is I shall pin that down while I flow some solder onto the pads. So it does have these, it does have 2 differently sized holes to make sure it goes around the right way, which is quite nice. I do have little domes of solder here that are just touching that up a little bit. Not to worry. Oh, this isn't working. Let's put a tiny little touch of solder on the bottom of these pads just to wet them. Am I going to regret doing this? Who cares? Everything can be fixed. And these pads are pre-tinned, so I'm going to put this on like this. This is when I'd probably want to press it against my front just to actually hold it in. The circuit board just so it held it steady, but can't really do that when I'm holding it out across my bench like this. So let's reflow that. That looks pretty good. And let's do the other pad, so I'll just flow some solder on first. And then I shall press it down while I'm reflowing that. And it was more or less in position anyway, and it's also getting jolly hot. Excellent. That's looking good. We have a TR, temperature sensor, I'm guessing, thermoresistor, thermistor. This is one where I'm going to very carefully, this is where I might actually do the bending of the leads, because I don't want to put any strain on this, so let's gently bend it like that. And I think the component can be laid down on the circuit board if needs be. So I'm just going to spread the legs a little bit. Spread those legs. Just to better fit the circuit board, because they've kept them quite wide. I wonder if it's the original component they intended to be used. I wonder if I'm putting the correct component in the correct place. Who knows? It's a temperature sensitive resistor, so let's give it some temperature to worry about. With a soldering iron. So far, the only polarity sensitive component I've put in has been the battery pack, and it can't go in the wrong way around. All the polarities are marked on this circuit board, I think. So that's good. I think they're marked on the circuit board. Yes, they are. So I'm not sure how close. This unit comes with these plastic covers and some spacers and bolts. I'm not sure. It looks like there's just one spacer between each side, so this thermistor may actually need laid down flat, so I shall bend it like that very carefully, but not actually touch the circuit board with it, so it responds faster to temperature changes. The displays themselves, I'm just going to place this on momentarily just to see how much space there is underneath. They have enough room underneath for the solder joints. That's okay, that's fine. And also they've strategically positioned it to become in between pins on the processor, which is quite nice. What shall we do next? Let's get the buzzer on. So the buzzer, does it have a polarity? I don't think it has a polarity. It does have a square pad and a round pad. That's a bit worrying. And it's got a plus and minus symbol. Oh dear. Normally I'd think it'd be nice if it was actually marked with a polarity. I'm a bit concerned about that. Does it matter? Is this just, let's get the meter in. Let's check if it's just a standard little sounder. We'll be able to test that with the meter. If I set it to resistance, and I'd expect somewhere in the range of 8 ohms, 32 ohms, 16 ohms, it's right in the middle. It's a 60 ohm impedance. If I get it the other way around, this is just it's just a dumb transducer. It's a little coil, so it's alright. It's a little classic little magnetic peeper. That's okay. Which is strange, because normally the square pin, would that normally be, hold on, let's just check this. Let's get the meter in again on continuity. And we'll check. I'm guessing that this capacitor here is for the incoming supply. I could be wrong. So the plus connection here, yeah, so the square connection in the buzzer is supposedly positive. Okay, that's fine. And it does have a plus symbol on the top, so we'll put it that way. I don't know if it is polarity sensitive, but we'll just put it that way. It just seems logical. I think it does seem to be just a standard magnetic peeper, so it wouldn't really matter if you got the polarity wrong. It would if it had active electronics in it. It wouldn't peep. Might draw a bit more current than you were expecting. might get unhappy and never peep again. Big flux skid mark there on the circuit board. Excellent, classy. What can I put on next? Let's put the capacitors on. So there's a little, I guess 104, could be wrong here. Where's my magnifying glass? 104, it's 100 nanocapacitor. That's 100,000. 104 means 1 0 and 4 zeros, so it's 100,000 picofarad, which is 100 nanofarad. And I'm going to solder one of the leads. Again, they've shown it polarized. They've actually shown a square pad for the polarity, which is nonsense because this is a non-polarized capacitor. So let's make sure that's sitting relatively square-ish, which it's not. Not to worry, I'll just square that up a little tiny bit. Doesn't really matter that much. It's a standard little ceramic capacitor. And then we shall put its partner capacitor next to it, which is the electrolytic, which is just for sort of higher level smoothing probably. There's no voltage regulation in this unit. It's relying on the 5-volt supply from the USB power supply for that. So here is the little electrolytic, which this one is critical. So the long lead is the positive and the short lead is the negative. The negative also has... Now, how's that going to be with the case here? Oh, that's odd. Yeah, this is a... oh, that's going in the front. So this is the back panel. Is this going to fit? I thought they might have actually had some sort of cutout for the sounder, but they've not. That's strange. That's not going to fit, is it? Oh well. So be it. So this capacitor is just going to be pressed in roughly the same height as the peepers, since there are no holes, and we'll just improvise with this later on. Maybe they're just expecting to sandwich the thing against the sounder, which seems a bit odd. So I've soldered one of the connections there. I'm just going to make sure it's square but without putting excess pressure on the electrolytic in case I rip its leads out. You don't want to apply too much angular pressure on these once you've actually soldered one lead in, because it can actually start pulling the pins out of them. I suppose that's one advantage of the surface mount versions. Okay, next I'm going to put on the transistor. Hopefully the transistor is the correct one for the job. It's just marked Q1, it's got an outline and it's on this side, so I'll just nudge it up a little bit, take the strain off it. And I shall solder. The pads are tiny. That is the smallest pads on the circuit board, is it not? They're really minute. So I'm going to solder one of them. It's fallen out. Let's put it in, and this time, just so it doesn't fall out again, let's bend the lead. Now, some people like to put the components through and then bend the lead absolutely to the side to hold the component in place. I don't like doing that. I find that just makes it very difficult to get a component out afterwards if you've soldered, if you need to change it for any reason, because it means that even when you've removed the solder, it tends to lie across the lead, the solder itself, and it just makes it very difficult removing components. So I prefer not to do that. So this is looking fairly straight. I've soldered one lead. Let's try to solder the middle lead without getting a big juicy blob across that, because this is super. This is almost like surface mount component level pad sizes. That's ridiculous. And we'll crop those leads like that. Next, I'm going to put in the socket. So which side does it go on? It will go on the opposite side from the displays. That would make sense because it's not going to poke right through the displays. So here's a little USB socket. Let's try and hold this in while I solder it. Oh, tricky. So I'm going to start by soldering one of the support pins. And I'm going to make sure, hot, hot, hot. I'm going to make sure that's sitting relatively square, which it is. That's nice. It's not sitting relatively straight, it's looking slightly squint. I shall reflow that at the risk of getting burnt fingers again and just sort of settle it up. It's perfect, it's fine, it's not going any further. So now this, I'm regretting having that fannytron now, because even though the temperature in the house is a staggering 8 degrees Celsius today, yeah, it's that cold. Because I'm used to living in the cold, that's actually quite I'm well dressed, so I'm like it's kind of hot, too hot. I've got a favourite pair of Canadian overalls, padded thermal bib overalls on at the moment. Tough Duck, they're called, and they're very nice. They're very super cosy, but then they're Canadians, so they would be. The Canadians know a thing or two about staying warm. Add that to a thermal fleecy jumper. I got these ages back. I got one for me, my brother, and my mum, because it's just a thing we did at the time, and yeah, we got lots of good wear out of them. They were great. I'm kind of tempted to flow a little bit of extra solder on this side for extra strength in this connector. Should I do that, or am I just tempting fate? Let's do it at the risk of tempting fate. Flow that on, just because it's going to give it a much stronger mechanical connection onto the circuit board. Or it's going to destroy everything horribly. Who knows? Am I staying in shot? Yes, I'm staying in shot, not necessarily central to the image, but staying in shot enough. Now let's get on to the chips. Now, I'll put the crystal on first. Now, the crystal does have this pad here, and normally you'd screen the case by putting it on that pad. I'm very cautious about that. I'm also very cautious about the fact those holes are splayed apart like that. Is that going to put a lot of strain on this crystal? It's not too bad. That looks okay. So what I'm going to do before I sit that in, I've formed the leads here. I'm going to put a tiny little touch of solder on the end of the case, because the less time spent soldering this crystal, the better, just to protect it from excess temperature. That is very fumbly. Okay, and likewise I'm going to put a little tiny pad of solder, just a wee smear on here, just to pre-wet that surface. And then I'm going to solder it in place. This is where I do burn my fingers just a little bit. Ow, 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 ow. That's it. And it didn't get too hot, and you can cool it down by putting your thumb on it and just absorbing that heat away from it. There's a little bit of heat left, but not that much. And let us solder those two pads at the back. Tiny little pads. They could have made these pads so much bigger, but they didn't. I guess they're using, they're passing tracks between the pads. No, they're not really doing too many. They're doing with some of them. One of the joys of microcontrollers is you can shuffle the pins with a bit of software. You can actually, if instead of having to juggle the pins around, if the data isn't coming out in the right sort of ideal arrangement, you can shuffle that so it kind of does. They're very versatile. So let's put the chips in now. Let's put the real-time clock counter. This is where I'm going to bring in, I'm going to cheat and bring in my little lead former. This little device, I got it a long time ago. It's a lead former. You place the component, the chip into it, and squeeze it shut, and it basically just aligns the pins. It's super simple. When I got this, it was quite an expensive tool, because it's kind of specialist, really, I suppose. I think they're available cheaply now. And it lines all the pins up so it kind of goes in perfectly. More important when you're dealing with IC sockets and you want all the pins to line up. So now, I'm going to solder diagonally opposing pins on this, and then make sure the chip is down flush against the circuit board. Normally I'd prefer sockets for such things like this, because it takes a lot of the thermal stress off the chip as you're soldering it if you can just put it in a socket. And it also means that should you wish to change the chip later on, it's just easy to pull it out and pop a new one in. So that is holding down nicely. in the right position. Let's flow a little tiny touch of solder onto each of the other pins. And then we're on to the microcontroller, the bit that's got all the brains in it. And I have a horrible feeling looking at some of the information about this thing in the internet that this clock isn't just going to be a simple clock, it's going to try to do far too many fancy things. It ends up that it spends very little actual time displaying the time. So the little indent is at this end, so I'll look on the chip and that indicates which end pin 1 is at. And we pop the chip in. And I solder diagonally opposite pins. And then I check I've put it in the right way round again, because there's no harm double checking. And that it's flush with the circuit board. It's in the right way round, as is that chip. It's flush with the circuit board. It's looking good. So I solder all the other pins. And once you get into a rhythm with this, because the pads are very small, it's taking the solder quite quickly. I'm just using the generic Chinese iron. One day I will take a look at, is it the TS100 type iron bits? They're very clever. I've got one of them here somewhere. I was intrigued at how it controlled the heating element and monitored the temperature with 3 connections. I just guessed that one was common. It's so much cleverer than that with those soldering iron elements. The common is actually just an earth connection, grounding for the tip, and it only uses 2 connections for both the heating element and the temperature sensing, because all it does is it's got a thermocouple in series with the heating element. So that all you do is you apply power to heat the heating element, and every so often you dip the power to element and then look at the voltage it's generating across that thermocouple, which is very clever, very simple, keeps the number of connections down to a minimum. That looks okay. I say it looks okay. It seems sparse, the solder, but mainly because it's been sucking in to the other side through the plated through hole, so it is making a good connection. Now, are these leads going to need cropped at all? Or is the display going to sit in? Now, here's another thing. There's no indication of which way the display goes up, and you think, does that really matter? And as far as I can see, if, say for instance, you've got a row of 7 pins at this end and 7 pins at that end, the only ones that appear to be connected are the middle pins. And I think, say for instance, the bottom left pin controls the left column. The top right pin will control the right column. So if you actually swap it round like that, I don't think it matters which way round it is. I could be wrong. If I am wrong, this clock is not going to work. But let's put the middle display in, since it's the one that's the most critical for sticky up solder connections. That's looking fine, and let's solder this. We're almost there, we're almost done. There's a spare button. It's always worrying when there's spare components. It's good there's spare components. When I sold fairground control modules to the ride industry, I always included a bag of spares, because it was so much easier for them to do that, for them just to have spares on hand. Even if they didn't use them, they ended up just sticking them all in a box, and it meant that if they ever lost a hardware pack, there was always going to be enough to actually put the thing together. It's nice when spares are included. It's a shame a lot of manufacturers don't include spares. So these are straightforward to solder in. It's green display I chose. The reason I chose a green display is because it's one of the brightest colours for LEDs. The gallium nitride green. I was tempted to go with the red one, but I noticed that because of the way they're using very simple drive circuitry with this, with just the minimum number of resistors, I noticed that because of that, it tends to look a bit sort of baddish. The LEDs don't all like the same intensity depending on which ones are lit. This is looking good. I just have 2 more displays to put in, and then we can power it up and see if it goes bang or doesn't work. Look at that capacitor. I've nudged it over. That's okay. It's fine. It's fine. Let's drop this in here. Once again, these displays have a plastic film across the front. I usually prefer to remove that. The reason it's there is to protect the display during shipping and also before it's used. against scratches, but it's also, I think, used as part of the manufacturing process, because this layer of plastic is put on and then it gets filled on the other side with resin, and that the plastic stops it while basically dribbling out. Let's put the other display in while I'm doing this. So here we go. The last two displays, I shall sit it down for this. I shall also focus down a little bit tighter onto that. I notice a slight time lag when I touch the screen there. The open camera, which I'm using to record at the moment, has just done an update and added features. Sometimes this is a disaster. Time will tell. Sometimes they add features in with good meaning, but well-meaning gesture, but then increase the processing power to the point that it affects the ability to record. That's usually the point I suddenly realise that I have to upgrade phone again as the software grows and the software updates that come from the manufacturers hobble the phone further and further, Windows and Apple style-y. Okay, and that just leaves 7 more solder connections, and theoretically after I've done this, we can just plug this in and it should start running, and then all that I have to do is then work out its huge complicated menu system and try and stop it making loud random peeping noises. What do you reckon? Is it going to work? There's only one way to find out. Let's remove this film. I prefer it with the film removed. It gives it a more matte surface finish. There we go. This is where some of you will suddenly realise why your display was so shiny and hard to read. Because it had this film across it and you didn't realise it came off. It may not actually come off. Oh no. This is where I've got the 2 outer displays, and now it might be folded down at the sides of the middle display. Hopefully I'll be able to fish that out without wrecking everything. This is where I cut the edge right off the display. Oh no, it's all gone horribly wrong. And I've not even had it lit yet. Let's use the spudger to try and lift that film out there. I think it's just very, very close to the edge. I'm going to end up scratching the display, aren't I? Yes, I am. Am I bothered about that? Not really. Yet removing the film is turning out to be one of the more complicated processes. There we go. Right, let's plug it in. I'm not sure what current this requires. I should hope it's less than an amp, so I'll plug it into this dinky little thing here. A little power bank. And we'll see what happens. I've not got a battery for it. Oh. Is it going to work? Uh-huh. It's working. Okay. Right. Oh, it is. It's doing that thing that's going to start sweeping through. Yeah, it's... Right, okay. Uh-oh. Right. It beeps. What happens if you have to hold? Uh-oh. 1, 2, 3... Actually, what time is it? Just give me a second. It's 0:45 AM. Is this a 24-hour clock? Oh, that's quite annoying. It is a 24-hour clock, so that's a 0. And does it have auto increment? Oh no, it doesn't. It just like skipped. That's annoying. What if I hold this in again? See, I haven't a clue how to... Oh no. Time. So if I hold this button in... Oh no. Alarm. Font. Oh no. See, it's too complicated. Mid-p. What the heck is that? FMT. FIMT. I haven't a clue what half these features are. I think someone's Oh geez. Right, okay. Time. I'm back here again. No, you have to push it each time. That is a really annoying little beeper. So it's now probably about 12:45. Why am I even doing this? Because that's 45. Oh, right, okay, so now I hold this button in at the left-hand side here. Time, click it once more. No, it's gone on to that. Oh, no. They've really squished it together, haven't they? I guess that's why they have to have the colon expanding the middle here. Though that sounds a bit rude, expanding your colon. Time. Oh, no, I've done it again. Time. If you click this one after you hold this one to put it into program mode, and then you click this one to go through it, and then it'll be like 2099. Okay, I'm guessing, let's go 2018. I guess that's what this is. Oh, I've gone 2000. Actually, it's 2019. That's a good result. 1531. I guess that is the day. So it's actually still January, isn't it? Right. Anyway, what's the other options you got here? Time, date, alarm. I'm guessing that would just let you choose on or off. Okay, that's quite handy that you can do that. Why is that pixel out there? And those actually, no, it's because those ones are ghosting. That's a bit of a weird thing. But you can see what I mean about the difference in intensity here, where the there's only just one pixel lit. It's a bit brighter. It's showing up in the phone more than it is in real life. But where you've got more lit in a column, because it's just using single resistor for them, it's causing that slight effect. Okay. And it is, I wonder if there's a way to disable the fact it's scrolling through those displays. I shall have to read up. So it's an easy enough kit to build. It comes with the plastic covers. The only real opening in the back is for, oh, you know what? See the buzzer here? It's flush with the top of the displays. And the capacitor is as well. So that means that when the front plastic gets put on, let's remove the film off this. When the front plastic gets put on, which is smoked plastic, for that designer sort of contrast look. This is where fingernails would have been quite handy, but I have trimmed them off. So this will sit down flush in the front, so I presume it just gets clamped down by the screws to create that sort of display. And the back panel has the outlet for the, it's got the cutout for getting your fingers in with the buttons, and also for the connector to poke through. And those pins for the displays just happen to be the same height as the integrated circuits on it. So I'd guess that they could be kept on and just used as spacers, although it does have little black plastic spacers included, which are around about the right height. So I guess that's what they're for. Right, well, I'm just going to pause momentarily and stick those on. And that is it. It's now displaying the correct time, which is 0:63 apparently. Let me just go and check something. Is that really just rolled over? Yeah, it's 12:51 and it's displaying that 0:63, so that's impressive. Let's time. Well, let's go back. Time. Oh, it needs it's not kept the time. Oh, that's not impressive. Oh, of course, no, there's no battery in it. That's why. Duh. That was a bit thick, wasn't it? Yeah, sorry. Big thick Clive. The reason that was garbled, the reason it displayed a random figure there is because there's no battery keeping the memory backup in the chip. So it actually just provided garbled time. So it's not that bad after all. Yeah, it's fine. I don't know how the timekeeping will be. This is bowed out slightly, which is a slight design weakness. It's very easy to over-tighten this because there's no spacer at the front. It really is just a case of snug it up until it barely catches. And the little plastic spacers go in the back for the chips and the connectors. But other than that, you know, it looks good so far, but time will tell. Time will tell how well it actually keeps time. So I shall give that a test and see how it goes. Worthwhile additional information now I've had a play with this. The standby current, the normal operational current, is 50 milliamps or less. It's not exceeded that during the testing. So let's zoom down in this a little bit and I'll show you the settings that we have here. If you hold the button on the left, it goes into programming mode and you've got the option of time, which will change the time settings, date for the date settings, alarm for the alarm settings, whether it's on or off. Font, let me show you the font options. It lets you change styles of the text. It's not super exciting, but it's nice having the option. The next mode after font is display, 1 to 5. Hold on, 1, 2, 4. Display, and this lets you choose the type of display. It's currently set to 5 for a reason. If you go to any other setting, like say for instance 1, and go back, it'll display the time for a while, and then it'll display the temperature. Then it will display the date. And then if it's in birthday mode, it will then display the sort of birthday message after the day. New Year. Right, okay, it's in Happy New Year's Day mode. Okay, that's not terribly helpful. I personally prefer just to display a clock. So for the clock, all the other ones display different sort of features. But the display, I want to select 1, 2, 3, 4, 5 is the only one that just displays the time on its own. After that, you've got mid-P. Let me show you the mid-P functions. So that's time, date, alarm, font, display, midpoint. And the midpoint, if I select it, just lets you choose the colon in the middle. Whether it's heavily animated or not, just the animation. That one's not too bad, that little one that bounces up and down. There we go. So next option, you have to go through them all each time you change something. Time, date, alarm, font, display, midpoint. FMT is time format. If I select that one, it's 12 or 24 hour. That's all the options. And there's those ghosty LEDs at the end. So that's fairly straightforward. Then we've got time, date, alarm, font, display, middle point, time format, birthday mode. If you enable birthday mode, you can turn it on or off. You can set a date and it'll say happy birthday on your birthday. It's a gimmick. And then finally, we've got, oh, I've just selected that one. So on or off is the options you have there plus the date. And the final option, the menu, because it's got 1, 2, 3, 4, 5, 6, 7, 8, 9 menu options. Time, date, alarm, font, display, midpoint, time format, birthday, and, oh, did I just skip out that? Let's try that again. Format, birthday, and brig. Brig stands for brightness, and it lets you choose level 1, 2, 3, 4, or 5. And that's more or less it. So my recommended settings, if you don't really need date information, if you just want a clock, are to set the display to mode 5 and just disable features like the happy birthday feature, because it's a bit odd. It starts off, it displays the first few characters, pauses, and then scrolls the rest across. But really, it's one of these things that if it's a clock, really, when you look at it, it should be displaying the time. And in any of the other modes, it's either going to be displaying temperature, date, day. It's not going to be displaying the time when you glance across and need to know, and then you wait for it to mince through its little routines. But it's looking good so far. So now I just need to get a little memory backup battery for it, because it wasn't supplied with one. And I can give it the final test of leaving it running and seeing if it keeps time, and then leave it on standby, and then running theoretically on the internal battery in the little real-time clock chip, and see if it keeps the time. So we'll see how that goes.